Now, to solve this question, you need just a little knowledge of trigonometry. The question is, in bracket, tan pi over 4 is raised to the power of 3x plus 1, which equals 2 raised to the power of x minus 2. Solution. Now, our main focus should be this bracket. This should be the major focus. In this bracket, we are having tan pi over 4. Tan pi over 4. Now, this pi is different from the constant pi, which is equal to 22 over 7. Yes, pi is equal to 22 over 7, but we are not referring to this pi. Angles are measured in either degrees or in radians. And if you are considering a circle, because angles are measured in degrees and also in radians, then one revolution or one circle in degrees is equal to 360 degrees. Then in radians, one revolution or one circle is equal to 2 pi rad or radians. But we are referring to this person as radian, and we are not considering the degrees. If you are comparing between degrees and radian, then 360 degrees is the same as 2 pi. That means pi will give 180 degrees. So we are going to use pi equal to 180 degrees. Pi equal to 180 degrees in solving this problem on the board. Hope you understood. Not this pi equal to 22 or 7. This is a constant term, while this is measurement. Constant term or numerical of value, while this person is a measurement of an angle. Let's solve this question on the board. Now, having known that, let's examine the parentheses, which is the bracket. In this bracket, we have tan pi over 4. Raised to the power of 3 raised to the power of x plus 1, which is equals 2 raised to the power of x minus 2. 2 raised to the power of x minus 2, but because pi is given as 180 degrees, we have to substitute. Then replace the pi with 180 degrees. Hope you understood. Alright, so from here we have tan 180 divided by 4 gives 45 degrees, which equals 2 raised to the power of x minus 2. Tan 45 degrees is 1. This is equal to 2 raised to the power of x minus 2. 2 raised to the power of x minus 2. Please, pardon, let's not ignore the power. So the power is 3x plus 1 and 3x plus 1. Next thing we have to examine is 1 raised to the power of 3x plus 1. This is very simple. Over here we have 1 bracket open, bracket close, 3x plus 1 is equal to 2 raised to the power of x minus 2. X minus 2. Now 1 raised to the power of this expression is going to give 1. How did we get 1? 1 raised to the power of 0 is 1. 1 raised to the power of 1 is 1. 1 raised to the power of 2 gives 1. 1 raised to the power of 18 is still 1. 1 raised to the power of 4 means 1 times 1 times 1 times 1, which gives 1. So for that reason, 1 raised to the power of this is also equal to 1. In other instances, 1 is the same thing as 2 raised to the power of 0. Anything raised to the power of 0, according to the zero index law of indices, must be 1. 2 raised to the power of 0 gives 1. Then, if we substitute 2 raised to the power of 0, 2 raised to the power of 0 into this, because 2 raised to the power of 0 is 1, we are going to obtain this. Then let's multiply. Power law of indices. If we have two different powers separated by a bracket, multiply them. So if you multiply, it will be 0 times 3, which is 0, and 0 plus 1, 0 times 1 is also 0. Then 2 raised to the power of 0 is 1. So we have 1 is equal to 2 raised to the power of x minus 2. Now let us apply the law of indices, multiplication law of indices right here. Multiplication law states that if we have a raised to the power of n times a raised to the power of n, provided the two bases are the same, we must add up their respective powers. That will give a raised to the power of n plus n. Now let's compare what we have here with this. It's basically the same. A base, a bigger number carrying 2 terms. A bigger number carrying 2 terms. Since that is true, let's convert this person into this form. Alright, let's do that. So 1 is equal to 2 raised to the power of x, a raised to the power of n times a raised to the power of n, 2 raised to the power of minus 2. This gives 1 is equal to 2 raised to the power of x times. Now at this point, let us apply another law of indices. At this point, we are going to apply the negative power law of indices that states that if we have a raised to the power of minus 2 is the same as 1 over a raised to the power of 2. Bringing this knowledge here, this will become 1 over 2 raised to the power of 2. Okay. So this gives 1 is equal to 2 raised to the power of x times 1 over 2 raised to the power of 2 is 4. 1 over 4. So this gives 1 is equal to If you multiply this by this, you obtain 2 raised to the power of x divided by 4. We observe that this left side is just 1, and this one is numerator and denominator, a fraction. Let's provide a fraction to this so it will look the same. Divided by 1. Now let's cross and multiply. If we cross and multiply, it will be 4 is equal to 1 times 2 raised to the power of x. 2 raised to the power of x. At this point, the right hand side is written in exponential form, while the left is not. Let's also change this form into its exponential form. That will give 2 raised to the power of 2, which is something as 4, equal to 2 raised to the power of x. This cancels this, and 2 is equal to x. So the correct answer is 2.